Hello everybody, I am Mark Carter. Thank you so much for joining me tonight. So as you can see, it's actually an incredibly gorgeous night tonight here in Kansas City, Missouri, just on the north side of Kansas City, in fact, in a little town called Smithville. So behind me, I have my entire rig here. I use the Telegizmos 365 telescope cover, which protects it in days like today where we hit almost 100 degrees Fahrenheit, which I think is like 34 Celsius. So on days like today, it gets very hot. So let's take the tarp off. So this particular telescope rig is really good for a multitude of targets. I've done everything from galaxies to nebulae so far, and I've been incredibly impressed with the optics of this carbon fiber apo triplet telescope. At 952 millimeters native focal length, it can look fairly deep. My skies, I found really anything above 1,000 millimeters is probably just really not worth shooting. You know, I've tried everything from 1,600 millimeters all the way up through 3,000 millimeters, and once you go above 1,000 millimeters, I just find that my skies really just don't promote those telescopes very well. So as you can see here behind me, I've got a lot of nothing behind me. I think the nearest house is about a quarter mile in that direction, and then there's a high school as well, and then over here we've got an event space. I'm able to stay relatively dark every single night. The only obstruction that I really have here is I've got a couple trees to this side of me on the west side of my house, and then I've got the house itself. The lowest I can shoot is the Orion Nebula during the winter months, and then the lowest I can shoot in the summer months is going to be Eagle Nebula. If I put it out in the yard, which I can do, my only problem is I've got an irrigation system. I don't know how many of you have had this, but I've literally woken up to my entire rig taking a bath. Electronics don't do well when they get that wet. So let's take a look at what equipment I'll be using tonight. We have the ZWO ASI 2600mm Pro, which is a monochrome camera. It is a 26 megapixel monochrome camera. 36 millimeter unmounted ZWO filter wheel, where I have 36 millimeter unmounted Optolong LRGB and Optolong's 3 nanometer SHO filters. Explorer Scientific 0.7 time reducer. Then I've got a moonlight focuser. Underneath the telescope, you can actually begin to see I've got a ZWO EAF on the bottom side, ZWO OAGL, and a ZWO ASI 174mm mini guide camera. A B-Link mini PC underneath here with a USB hub, as well as the Pegasus Astro pocket power box, do not do straps, and then a Optec flip flat. So right up here I have the Optec flip flat, and what this actually does is I can tell Nina to make this open automatically. I can tell Nina to also shoot my flats and dark flats by opening and closing this and turning on the light. At the base I've also got the Ioptron Sim 70. I do have a lot of issues with this particular mount, particularly when it comes to just getting it to connect. I have a lot of issues with that. I do find it is a mount that I personally cannot recommend to anybody to purchase. I've had nothing but issues with it. Once I'm connected, it does fine. But I have so many problems with getting connected. I've worked with their support. Everything they've given me has not worked. And what doesn't make sense is one time it boots up, it works just fine. The next time I boot it up, and I can literally leave it in its current place, exactly as you see right here, and these cables won't move. And then the next day, like today, it may not even connect. And I might spend 20 minutes just trying to run through the connection process. So tonight's target is actually going to be M63, which is the Sunflower Galaxy. I will then be switching over to SH2-115 in the constellation of Cygnus. What's nice about this particular nebula is there's a ton of hydrogen, which is pretty common with all nebulas, except there's also a huge amount of oxygen that's been ionized in that region as well. So it makes for a really turquoise bluish green color, which really makes the image pop. And so I'm often asked, how do you do your processing? So I use Nina on my onboard mini PC, which does the actual acquisition data gathering. Astro Pixel processor, which I've actually posted a video to. I'll see if I can either link it up top or I'll put it in the description below of how to use Astro Pixel Processor to do your stacking and calibration frames. I move on to PixInsight. And then I also use Photoshop because I do find they complement each other. I don't think one is superior entirely over the other. I think each have their own benefits, and I like to make sure I'm using every single one of those tools possible to produce the best possible image. So with that, I'm gonna go ahead and wait for it to get dark at this point. So one of the biggest problems that I personally face is I've got an 8-month-old son. He likes to wake up at the oddest hours, and makes it really inconvenient for me whenever I'm trying to do some of these things, and also my wife as well. So using a refractor makes it very simple for me. I can set this up and go. I don't have to collimate, I don't have to do anything crazy. Orientation stays the same every single time. I know it's at 92 degrees, and I'll show you that later. And so it's not gonna be actually dark until about 9:50, so we've got about 2 hours to go. I'm already set up. We're gonna go set up Nina, and I'm gonna show you how I do that. Okay, and we are now looking at what Stellarium looks like. We could do an entire video of just going through Stellarium. The key things we're going to do here, though, is we're going to turn on our telescope view, which is going to be this second icon right here. It's going to load up my ASI 2600mm. It's also going to pull in my Explore Scientific 127 carbon fiber, as well as my 0.7 time reducer. So the first thing I'm going to do is to get out of this full screen view, you press F11. And we'll maximize it again because I want the windowed view. Then we're going to press F5, and we're going to set our time of 2200. And that gives me a pretty good idea of what the sky's going to look like at 10 o'clock. And that's about when I'm actually going to begin imaging once Nina has taken over. Down here at the bottom, I'm going to click the play button because that will actually go ahead and pause the celestial skies movement. Just want to see what it is at this particular time. So we can press F5 again. Now I want to press D as in dog on my keyboard, and that's going to pull up our catalog of deep sky objects. So the first target we're going to be shooting here, and I'm going to press F3 to get my box to pop up. It's going to be M63. I'm going to go ahead and use it for my pre-selects. And it's going to take me there. With this view in Stellarium, I can now see what it is I'm targeting to shoot. And I can change my orientation. I can do all my planning right from here. Then, what I'm going to do is at 11 o'clock, so I'm going to go ahead and press F5 again and add 1 hour. So now we're at 11 o'clock, which is 2300 hours. I'm then going to do F3 again. And we're going to do SH2 115. This is my framing right about here. So you'll see I get this little bubble in the upper left hand corner, but I also get SH2 112. So what exactly are these Sharpless targets? It's really just hydrogen rich emission nebulae areas that also have some oxygen in it, and that's where we get some of our coloring. They also have some sulfur to it, and that'll also kind of pitch into the coloring as well. So this is generally where we're going to be operating, is these two areas. Now if I go ahead and I pull up Nina, I had all of my items already set up. The reason why you're seeing it blank is when I went back to look at my video, I didn't turn on my microphone. So I've recorded just over 10 minutes of video for you guys that had no sound. So I've got to do it again, and when I connected with Nina, all I had to do is press this connect button and everything will connect automatically for me. With my sequencer, I go to advanced sequencer. I'm going to say open. And right here I have my M63. So the way this is going to read is I'm going to message myself if there's any errors following all of this. We're going to wait until astronomical dusk minus 10 minutes. That way the camera starts to cool ahead of time. And by the time I start imaging, it's actually astronomical or nautical dusk. And we can start imaging truly at that time. It does take about 10 minutes to run through. Cooling the camera, unparking the scope, turning on the dew heater, opening the flat panel, and beginning to actually do calibration with PhD2, which is a part of the next section here of M63. And then at 11 o'clock we will stop imaging and we'll go to the next target, but until 11 o'clock we will loop through this cycle here. So what I'm going to do is go ahead and minimize this now, because we're at 11 o'clock. We're going to go SH2 115, and then until nautical dawn, which is 4:38 in the morning, I will continuously loop through. We're going to run the in sequence, which will close the flat panel. It will park the scope and turn the dew heater off as well, which this one doesn't have it set, but I know I have it set on my mini PC, which drives the actual program. Then it will automatically shoot my flats for me. Alright guys, so at this point, let's see what we got.